somebody asking, what is it? Yeah, I say identification of gases. You heard me right. Another word for it is test for gases. There are so many gases out there in the laboratory prepared, and students are always tested on how we can identify these gases, on your knowledge of these gases. And this test is going to be carried out either in the laboratory or in your different workshops. Today I'll be discussing this test for gases, and there are so many gases I'll be talking about today. We have your carbon 4 oxide CO2, you have your nitrogen 4 oxide NO2, you have your hydrogen gas H2, your oxygen gas O2, your HCl, which is hydrogen chloride gas, we have your ammonia gas NH3, we have your bromine gas, iodine, chlorine, hydrogen, just to mention but a few. Today we'll be looking at them and how you can identify them, confirm them in the laboratory. Gases are usually given up when certain substances are heated, or when you react or treat some substances with mineral acid. This mineral acid include your hydrochloric acid, your tetraoxosulfuric acid, your trioxonitrate 5 acids. Now, when these gases are given up, you are tested for and identified. They have peculiar properties, they have peculiar reactions, they have peculiar identification nature. And these properties include the color, the odor, the solubility in water, the action on litmus paper, and specific chemical tests that can identify and confirm these gases. I'm going to start today by discussing carbon 4 oxide, CO2. Yes, carbon 4 oxide. Now, carbon 4 oxide is a colorless gas. It's odorless too, doesn't have any odor. But of course, when it is tested with a damped blue litmus paper, it turns a damped blue litmus paper to red. This action shows that the gas is acidic, so it's an acidic gas. Yes, you heard me. Gases can be acidic, and carbon 4 oxide is an example of an acidic gas. To now confirm that this is carbon 4 oxide, when you bubble it through lime water. Yes, what is lime water? Now here, are you asking already? Lime water is aqueous calcium hydroxide. When you pass carbon 4 oxide through lime water, it turns lime water milky. A milky nature of carbon 4 lime water shows that carbon 4 oxide have been passed through it, and that's due to the formation of calcium trioxocarbonate 4. Yes, calcium trioxocarbonate 4. If you expose this lime water to excess carbon 4 oxide, this milky nature or milkiness will disappear due to the formation of a soluble calcium hydrogen trioxocarbonate 4. That's the test for carbon 4 oxide. I'm sure you remember when you come across a question on it, and you give it the best shot. The next one is sulfur 4 oxide. Yeah, sulfur 4 oxide is SO2. It's a colorless gas, but it has a pungent smell. Some people say it has an irritating smell. Pungent, irritating, choice of words. Now, it also turns a damp or moist blue litmus paper to red, showing that it is what? Acidic. But unlike carbon 4 oxide, sulfur 4 oxide decolorizes KMNO4, that is acidified potassium tetraoxomanganate 7. It removes the purple color to colorless. That's what we mean by decolorization. And it can also remove the color of potassium heptaoxodichromate 6 from the color of yellow to green. And this shows that potassium heptaoxodichromate 6 have been decolorized. This singular action shows you that sulfur 4 oxide is a reducing gas or reducing agent. Did you hear me well? Yes, it's a reducing agent. This may come handy if you are asked to give example of reducing agent. My wonderful series. This series is quite interesting. I wish we could practicalize it. But for today's purpose, I'm doing it to remind you of how to identify gases. My name is Mr. Philip Mamat. As usual, follow me and you'll be glad you did. The next gas is hydrogen sulfide. Did you hear me? Hydrogen sulfide. The formula for hydrogen sulfide gas is H2S. Hydrogen sulfide gas is colorless, but it has a rotten egg smell. Yes, did you hear that? Rotten egg smell. That's how to identify hydrogen sulfide gas in the laboratory. And Obviously, it turns a moist or damped blue litmus paper to red, which shows that it is acidic. But that's not the confirmatory test. The confirmatory test for this hydrogen sulfide gas is when a paper that is soaked in lead 2 ethanoate is passed to, or the gas is passed through it, it turns blue-black. This blue-black is due to the formation of lead 2 sulfide. Good. I'm glad you are following, and I'm sure you're understanding the concepts, my wonderful students. As we proceed in our lessons today, we'll be looking at other gases. These other gases include hydrogen chloride gas, HCl. When it is HCl gas, it's called hydrogen chloride gas. But if it is HCl aqueous, it's called hydrochloric acid. Today we'll be talking about hydrogen chloride gas. Hydrogen chloride gas is colorless with a pungent smell. Remember, pungent smell can also be referred to as an irritating smell. It turns a damp blue litmus paper to red, which shows that it is acidic. Yes, HCl gas is acidic. And how do you confirm the presence of HCl? When you bring or introduce a cork of concentrated ammonia gas to a place where there is hydrogen chloride gas, a white dense film is formed. And oftentimes my students call it smoke without fire. So HCl forms a dense fume with ammonia vapor or ammonia gas. That's the confirmatory test for this HCl gas, and this is due to the formation of ammonium chloride. Yes, ammonium chloride can sublime. Do you remember that? If you do, then you are a good chemistry student. The next one is nitrogen 4 oxide. There are gases that are colored. Nitrogen 4 oxide is one of those gases. Nitrogen 4 oxide. The color is reddish brown. When you see a reddish brown gas, what should come to your mind is nitrogen 4 oxide. It's not the only gas that is reddish brown though. A bromine can possess the same color, but nitrogen 4 oxide will turn a damp, moist blue litmus paper from blue to red because it is acidic. Now we refer to this as acid anhydride. We refer to them as what? Acid anhydride, because they are gases that dissolve in water to produce the corresponding acid. Now, how do you confirm the presence of nitrogen 4 oxide? The confirmatory test for nitrogen 4 oxide is if a starch iodide paper is used, it turns blue-black. If a starch iodide paper is used, it turns blue-black. That means when you pass your nitrogen 4 oxide over a starch iodide paper, it turns it to be blue-black. Our next gas is chlorine gas. Yes, chlorine gas. What is chlorine gas? Chlorine gas is, the name chlorine is gotten from the color of the gas, which is greenish yellow. Greenish yellow is the color for chlorine gas. And chlorine gas will usually turn a damped blue litmus paper from blue to red, and eventually it will bleach the litmus paper. It will bleach the litmus paper because of the bleaching action of chlorine. Now, how do you confirm our test for chlorine in the laboratory? Chlorine, just like we have said earlier on, will turn a starch iodide paper blue-black due to the displacement of iodine. Yes, displacement of iodine. Chlorine will displace iodine in a reaction. My wonderful student, I'm glad you've been enjoying this series. We will continue shortly. And you will get more tips on the gases that you are going to be identifying. My next gas is ammonia gas. Ammonia gas, yes, ammonia gas is very, very peculiar because it's the only gas at this level that can turn a red litmus paper to blue. Ammonia gas is a colorless gas, but it has a choking smell. It has what? A choking smell. This smell usually is a characteristic of ammonia gas. And ammonia gas can be tested in the laboratory just like when we tested for our hydrogen chloride gas. When ammonia gas is brought close to a cork of hydrochloric acid or a cork to a container of hydrochloric acid, the vapor of hydrogen chloride or hydrochloric acid will give a white dense fume when ammonia gas comes in contact with it. Remember I said it's due to the formation of your ammonium chloride, which can sublime. My wonderful students, how time flies. As we round up today, we'll be talking about hydrogen gas. Unlike the gases that we have discussed earlier, hydrogen gas is neutral to litmus. It means it doesn't have any action on litmus paper. But hydrogen gas is colorless, is odorless, and of course the confirmatory test for hydrogen gas is that it gives a pop sound. Pop, P-O-P, when a flame is passed over it. This is due to the violent combination with oxygen. When hydrogen combines with oxygen, this reaction is usually violent. Don't try it because it's dangerous. So the pop sounds indicate that the gas, wow, very common gas that we all talk about. We breathe in oxygen. Oftentimes we talk about we breathe in oxygen. How do you identify oxygen in the laboratory? Remember, oxygen is also a colorless gas and it's also odorless. Just like hydrogen, it has no action on litmus, meaning that it is neutral. It's neither acidic nor basic. Then how can you confirm oxygen gas in the laboratory? Oxygen gas rekindles a glowing splint. In other words, oxygen gas relights a glowing splint. If a splint is going off and you introduce oxygen gas, this flame or splint will rekindle, and that is because oxygen supports combustion. Oxygen supports combustion. There can be a combustion without oxygen. If you want to try that out, lit a candle in the room, cover it with a container like a bucket, it will automatically go on. Why? Because of the absence of the presence of oxygen. Ladies, my distinguished students, at this point I'll be rounding up with the last gas, which is water vapor. Water in gaseous form is called water vapor. When water vapor is given off in the test tube, one of the ways to know is that the test tube becomes wet. Yes, it becomes wet at the tip where the temperature is less than where it's coming from. Obviously, today in our lessons, we have learned quite a number of gases and how you can test for them. The last one is our water vapor. Now, how can you test for water vapor? Remember, water vapor, just like hydrogen and oxygen, is colorless, odorless, and neutral to litmus, meaning that it does not have action on litmus. You hear that well? It does not have action on litmus. How can you confirm the presence of water vapor? It turns anhydrous copper 2 tetrasulfate 6 from white to blue. It turns anhydrous copper 2 tetrasulfate 6 from white to blue, and also it turns anhydrous copper 2 chloride from blue to pink. This action only can identify. My wonderful students, time has gone. We have spent quite discussing tests and identification of gases. I'm glad that we followed. I'm happy we are going to pick some very important things here. But before I go, I have mentioned the word anhydrous, and many of you are already thinking, what is anhydrous? Now, there are substances that are anhydrous, meaning they don't contain water or crystallization, and other substances are hydrated. The difference between hydrated compound and anhydrous compound is that hydrated compounds contain water of crystallization, and anhydrous substances do not contain water of crystallization. What is water of crystallization? It's a definite amount of water molecules in one mole of a substance. Substances like copper 2 tetrasulfate 6 can have 5 water of crystallization, and we call them copper 2 tetraogosulfate 6 pentahydrate. That's what we use in treating our swimming pools, so that algae don't grow on our swimming pools. Oftentimes when we go to a swimming pool, we see it's looking blue. That's the color of copper 2 tetraogosulfate 6. I had a swell time discussing chemistry with you. I hope you join me some other time. You can link my YouTube channel to find more lessons on chemistry. I'm your usual host, Mr. Philip. Thank you.